Here's a question. You have a list of numbers and a target. Can you find two that add up to it? Say the list is 2, 7, 11, 15. Target is 9. Which two? Pause for a second. Yes, 2 plus 7 is 9, so the answer is those two numbers, at positions 0 and 1. One careful thing. The problem wants the indices, not the values. So we return 0 and 1, not 2 and 7. Okay, try the obvious thing. Take the first number, 2. Now scan the rest looking for 7. 2 plus 7, 9. Found it. Lucky. But what if the answer was hiding much further? Then we move on. Fix the second number. Scan everything after it. Then the third. Then the fourth. Now picture this with 10,000 numbers. We're checking roughly 50 million pairs. That's slow. That's O of n squared time. 2 loops, each going through the array. We can do better. Let's slow down here. Look at what we already know but throw away. At index 0 we have 2. Target is 9. So we need 7. We already know what we're looking for. So here's the question. What if every time we saw a number we could ask, instantly, have I seen 7 before? That's a hash map. Think of lockers with name tags. You give it a number, it hands you back where you stored it. Instantly. Watch out though. You might be tempted to store the index as the key. Don't. We look up by value, so value is the key, index is what's inside. And the rule that saves us. Check the map first, then store. Otherwise a number might match itself. Let's walk it. Index 0, value 2. Complement is 9 minus 2, which is 7. Is 7 in the map? No, map is empty. So we write down 2 lives at index 0. Move on. Index 1, value 7. Complement is 9 minus 7. That's 2. Is 2 in the map? Yes, locker labeled 2. Inside is index 0. Return 0 and 1. Done. We never had to look back through the array. Notice what just happened. We never rescanned. Every number got touched exactly once, because the map remembered it for us. That makes it O of n time. O of n space for the map. Memory for speed. Okay, same logic, now in Python. We define the method and create our empty map. Loop through with both the index and the value. Compute what we need. Check the map first. If the complement is there, we return its stored index alongside the current one. Otherwise, store the current value with its index, and keep going.